might look a bit strange. You might think I look a bit strange. And the reason is it's because you're looking at me through a fisheye lens. Makes me look like a fish a bit, doesn't it, really? Well, we're surrounded by lenses here in the studio, and you're probably surrounded by a few. If you look around, you'll see what you can find.
Cheers.
Looking at things through glass and other see-through material can have an effect on how they look. Sometimes some people look better that way.
Oh, thanks very much indeed. Well, we all know that a magnifying glass can make things look bigger, but of course there are lots of other things that magnify as well. I mean, take this plastic sweet box. It's got water in it, and underneath there's writing, so that if you look through, the writing looks perfectly normal. But if I float a few drops of cooking oil on the surface, like this, and you look through the oil at the writing, you can see that it magnifies. Try it, and while you're at it, change the height of the water and see if that does anything different. Now, although the water in that box didn't, you can get water to magnify. Just get a clear pot like this one, and all I've done is stretch a bit of cling film over the top. And I've cut the bottom out of there, like that. Now all you've got to do is pour some water into it, like this. Whoop. And look at some writing through it from the top. Try it for yourself, and try using different sized yogurt pots as well, and see if it makes any difference. So what do these three magnifying lenses have in common? Well, here is a little clue.
Which way is the arrow pointing? To the right or to the left? Well, actually, it's to the right. You could try that for yourselves using different shaped bottles like these. And perhaps you could change the liquid inside the bottles to see if that makes a difference. For example, is the colour important? Or is the thickness of the liquid more important? Now, if a bottle full of water can change the direction of an arrow, what could it do to a beam of light? Perhaps we could have a little bit less light in the studio, please. Lovely, thank you. Right, as I shine the torch, you can see that the light is concentrated on the piece of paper. It's been focused. As I move it away, you see it's changing. It's not as good there, but there I can bring it back into focus. Now, will this happen with an empty bottle? Let's have a look. Well, it's not as good, because there doesn't seem to be much change in the beam of light. Why not? Or perhaps it's the water that's responsible for the effect. So let's have a look. We have some water in this container here, and if you could have a little bit less light again, and I will shine the torch into the water, see what happens as the beam enters the water.
Most things you can see through bend light, like glass, and we use this fact in all sorts of situations. See if you know what this is. Okay, there's the glass. We're looking out at something and it looks very weird. There's a light bulb. The glass is shaped like a dome. And it's sending light messages. That's a bit of a giveaway. And that's the answer. And we were inside the special glass lens at the top of the lighthouse. Each lighthouse has its own signal. This one at Nash Point in Wales flashes twice every 10 seconds. And the lighthouse keeper has to check that it's flashing correctly. When ships see the flashes, they know exactly where they are. The light passes through the specially shaped glass, and most of it bends out to sea. What do you think would happen to the light if there was no glass lens there at all? At night, you can see the lens clearly. And for ships out at sea, the light shining into the darkness can be a matter of life or death. This shape is called a prism. It's made of solid glass. Now, looking through it, it's quite weird. But the important thing about it is its shape.
That's right. And here we have another prism. Now, this is the same sort of thing. You can see it's exactly the same shape, except this one is full of water. It's a water prism. Now, if you pass white light, which I've got some coming from this projector over here, and you can see it hitting there on my hand, through this water prism, you get a rainbow appearing on the screen over there. And you can see all the different colours we've got. We've got purple and green and yellow and orange. And this shows that the white light has been separated out into all those different colours. Now, there are other ways of producing a rainbow. All you need is a bowl of water, a mirror, and the sun. Well, they wouldn't let me out of the studio, so I'll have to use this projector again. Now, here you can see the mirror, and there's the bowl of water. And the light is hitting just on the mirror, just there. And this produces a rainbow. There we are, you can see it just there. Very nice. Well, why don't you go outside on a sunny day with your mirror and your bowl of water and have a go for yourself and see how many colours you think there are.
Who needs prisms and bowls of water when you can have the real thing? I have the sunshine, so what am I going to use instead of prisms? Rain? Cue rain! Rainbow!
What a show! Rainbows are so amazing. But colour also has its uses. Different colours, different messages. Ships have lights, one on each side. Why do you think they're different colours? Oh, a spot of trouble, I think. Oh, what do you think that means?
Assault and rescue at HMS Victory, and you've seen a red flare in the middle of the harbour. Yes, you can see a dinghy.
Frank, scramble the helicopter.
Unit 483, you're clear backtrack if you wish.
I'm going to go off VHF myself.
Okay, John, that's fine. I'm going off all radios. Right, that's the guy. It's confirmed there's Delta 57. Okay.
Vernal, winching down out the door.
Okay.
And he's out the door, winching out. Please come forward at 30. Still a good line, good time. Just about to enter the water, and he's in the water and start control. Forward 10. Forward 8. Forward 5. And steady, 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 steady.
Red light, yellow light, blue light, but the bulb is white. So one simple way of making coloured light is to start with a white light and use different pieces of coloured plastic called filters to produce coloured lights. And here is a bigger way of making coloured lights. A set of traffic lights, red, amber and green. But are they? Let's take a closer look at the red light. Here's one that I've taken apart, and as you see, the bulb is white. The red light is produced because there is a red filter in front of the white bulb. The same is true of a ship's light. Inside here, we have a white bulb, but the colour changes according to the filter. And the light on the back of the bicycle. Thank you, Carmen. The same principle applies. It's a white bulb, but the colour is produced because of the red filter. Right, this time, instead of looking at coloured lights, try looking through coloured filters at other brightly coloured objects to see what happens.
If you haven't got proper filters, there are plenty of things you can try. I've got some sweetie wrappers here. This purple one's quite nice. There's also a nice yellow one. Plastic ones, anyway. But we're not the only creatures who use colour to communicate. Plants and animals do the same. All these flowers are using colour to advertise themselves. But what are they advertising, and who are they trying to attract? Insects visit the flowers for food, but what do the plants get in return? Birds also use colour for signalling, but funnily enough, it's usually the male birds that are brightly coloured. Some monkeys are pretty colourful, some more than others. They mix expression and colour to send different kinds of messages to each other. He's letting his family know who's boss. Yellow and black spell danger. It's poisonous. But these guys are just pretending so they get left alone. Here's a very different use of colour. How do you think it helps these creatures? All colours show up well in white light, but have you ever noticed the colour of cars under yellow street lights? Well, have a look at this fire engine. Well, obviously in white light it looks red. Under yellow street lights, what colour does it look? So next time you're out at night, see if you can make out car colours. Coloured lights show up very well in the dark, and some of them are meant to be obeyed.
Red.
Oh, he's obviously just jumped the lights. I'm sure he got a heavy fine for jumping those lights, and he deserved it too. Interestingly though, did you know one of the first automatic traffic signals was invented by the American Garrett Morgan in 1923? That's him there. But in Britain in the late 20s, traffic signals were still operated by hand. And guess who got the job?
Oi, can't you see the lights are red? Now then, if you were around in 1929, this is the sort of thing you'd see. Traffic lights were controlled by turning a handle, like this. The handle turns these 4 wheels in here. Each wheel is part of an electrical switch, and as the wheels go round, the switches go on and off. And this makes the lights change. All right then, Alan, put your foot down. Let's see if we can go forward a few years.
Baby, you can drive my car. Baby, you can drive my car. And baby, I love you.
In the 1960s, this is the kind of thing that controlled the lights. It hasn't got a handle because it's automatic. It's obviously a lot more complicated. It's full of wires and switches and other bits of spaghetti wiring. And all these things here are the switches. Now you can already see the red light, but if I push this switch in here, you can see that brings in the amber as well. And all this stuff over here is the electric timer, and it chooses the time for each of the switches to go on and off. And if I push this down, that sets the timer going. And now, forward to the future.
You go way too fast. Don't slow down, you're gonna crash. You should watch what you're staying.
This is one of the most up-to-date computers controlling traffic lights today. Here, it's only controlling one very simple junction, but it can control many more. In this model of a big city roundabout, it's controlling 4 sets of lights. Take a look at this.
Look at you guys.
Oh, there is trouble.
Ellen, my gran's got a suit like that.
Yeah, perhaps you should try wearing it, Carmen.
As for you, Paul, you're redundant. Traffic lights are automatic now. Do you think you could make something which would send light messages automatically? There's a poser for you. Let's get out of here. Ellen, give us a lift.
Hey, where do you think you're going?